This slide and the next one are really insulting. Bear with me. Very simple. What happens when you make a product? Make this really complicated stapler. It goes in a box. Boxes go on a pallet. I'm not going too fast for that, right? Yeah, they didn't understand this at all. So the boxes get wrapped in shrink wrap, and some guy in a forklift puts them on a truck. Truck goes to the port. If it's coming from overseas, the container ends up on a ship. We've done it this way for a very, very long time. And then we reverse the process. The ship comes into the port. Put the box back on the truck, you put it back in the warehouse, the guy in the forklift takes it off the truck, take off the shrink wrap, take it off the pallet, take it out of the box, and send it to the end user. A million products a day work this way. Someone has to order boxes, someone has to order pallets, someone's ordering shrink wrap, someone has to drive the forklift, someone has to do all the accounting, all the paperwork, all the shipping logistics, all the warehousing. And someone comes along and says, we can make this product with 45% fewer parts. What just happened to all these steps? Some of them are going to stay the same. Some of them will be diminished. I'm saying they're going to go away, but some of them will be diminished. Go to the next slide. When we talk about 3D printing, and this makes perfect sense, we talk about the printers. We talk about the technology of the printing. We talk about the filaments. We talk about the companies that are leading the technology in this. What we don't talk about, but it's actually the bigger story, it's the much bigger story, is how many jobs are impacted by being able to make something with fewer parts. By my count, what I can see is that this stapler, I think, is about 22 parts, and I look at it and count them all up. If it were just made by 12 parts, you impacted the suppliers you have to negotiate payment terms with. You just simplify your lead times. Remember I said this one wants payment 45 days, we take 30 days. This supplier needs 6 weeks, this supplier needs 3 weeks, this supplier needs 2 months. You just simplify your shipping lead times. Your purchasing department will cut that many fewer purchase orders. There's less packing, less boxes, less shrink wrap, less pallets, customs paperwork, bill of lading, certificate of origin, certificate of origin, bill of lading, packing slip. You just reduce your paperwork. You reduce the number of suppliers you have to invoice. You reduce the total number of checks that are going to get cut. Fewer products are going to end up in the warehouse. The packing, the shipping, logistics, and the cash flow. You don't hear people talk a lot about cash flow with 3D printing. But very common in the manufacturing sector is the suppliers want to get paid. You're still waiting for money from your customer. So what if you have fewer suppliers you have to pay? I mean, the traditional way to do it is you go to the bank, you get some kind of revolving credit, and then you borrow money against your revolving credit, for which you pay interest, and then you pay your suppliers while you're waiting for your customers to pay you. And then someone says you go from 22 parts to 12, and now you just reduced your lead times, you reduce the cash you have to send out before you get paid, you reduce the interest you have to pay, you just improved your cash flow. If you just focused on 3D printing, the technology and the printers, I said, that in itself is a big story. But that big story is at the very beginning now of writing an enormous story. This represents millions of jobs around the world. Millions of people go to work every day, and this is what they do. And if you have a technology now that can drastically reduce how many parts you need, how long it takes to get it to market, to get it produced and get it to market, you're impacting a vast amount of the workforce. It's not something we think about with 3D printing, but it will absolutely have an enormous impact. 5 years, 15 years, 20 years, forget about it. Businesses will do business on a day-to-day basis, radically different than they do it today. What's to come? If you can make a 3D printer that NASA can use a rocket, 30,000 RPM, minus 240 Celsius, and so on. Well, why isn't General Motors, using 3D printing more in production, or Toyota, or whoever? And the big issue has been speed. Traditionally, the two big limitations in 3D printing has been the diversity of the material, and it's a slow process. So I'll give you a great example of this. I have a 13-year-old son. I printed him a Darth Vader fighter, which makes me, for 20 minutes, a cool dad, and goes back to regard me the rest of the time. But it took me 6 hours to print this. You could injection mold this in, a minute and produce 1,000 a day. So 3D printing is traditionally been slow, but there are at least 3 companies I know of, XJet, Carbon 3D, and Quinnipiac, who have really tackled the speed issue head on. I don't believe any of these are in market yet. Quinnipiac is supposed to be in market this fall. XJet is finally releasing some animated graphics of how their technology will work. Carbon 3D has been giving their printers to, I think, Ford Motor Company, Walt Disney, and another well-known name, to see what they can do with it. This one, if you want to see the full talk on that, go to YouTube, pull up TED Talk Carbon 3D. It's 10 minutes, and he actually produces a very complex geodesic shape in those 10 minutes, which takes some guts. And while he's doing it, he's explaining how their process is multiple times faster than the process we've had in the past. Same with these others. When I say what's to come, what's coming now is speed. Speed combined with diversity of materials. So it's a very, very likely bet that engineers and designers, even architects, will now start to say, hey, we can take advantage of things we've never taken advantage of before. You'll see more efficient products, you'll see them produce faster, and you'll see them produce for less money. Speed is coming. And diversity of materials. Just this past December, The Economist did a report on material sciences. Now, this is not 3D printed, and I don't believe these are 3D printed. But what they were saying here in this is that whether it's 3D printing or other applications, we have finally, with nanotechnology and the ability to manufacture at the molecular level, we have finally really broken this open. And there was a quote in here. The quote blew me away. And I'm really taking it. Go to the next slide. I don't know who this fellow is, Gerbrand Seeger, but he's, I didn't go to school up there, did I? I was very smart. University of California, Berkeley. So in 1988, he got his master's in metallurgy and applied material sciences. By 91, he had his PhD in material science and engineering. This is someone, I don't know this person, I've never met him, I certainly would like to. But in that write-up in The Economist from December, where they talk about the advances in material sciences, this guy, who to me would be the right guy, says we are coming out of an age where we were blind. Out of an age we were blind? We built space shuttles. We built 777s. We built submersibles that can go 10, 12,000 feet under the ocean. We build incredible things. So if you don't have an engineering background, and I don't, if you don't have a technical background, I don't, I would look at the materials we've already been able to manipulate to some really tremendous things and think, wow. And this guy who would know, a guy with a PhD, who's had it for 20 years, is saying, we were blind. That's an incredible statement. He's realizing now, between the breakthroughs in material science and technologies like 3D printing that allows you to manipulate those materials in geometries you never could before, now we're really going to see some incredible stuff. That's a stunning quote from a guy who's absolutely a credible source to say. Before you play that, I wanted to, a few more slides here. I thought we'd end it with, almost ended, with what I thought was a pretty extraordinary use case, and then we'll end it with kind of a silly one. So this is something that's not going to happen. This did happen. There's a fellow in Spain walking around with a 3D printed rib cage in his chest. I want to play that. It's take about 2 minutes. Play again.
CSR in conjunction with Anatomics has developed a sternum implant for a patient suffering from cancer. It involved a very complex, world-first procedure. Anatomics contacted CSIRO. We have access to an electron beam metal printer, which means it's a really high-quality implant. And we also have the experience of having done these types of jobs before. So 3D printing works by inputting a 3D digital CAD file into a computer, and then that computer talks to the machine. The machine puts down layer upon layer of material, and each layer is fused. So as each layer is fused, you then start to build up the product as your layers increase. And Anatomics and the surgeon worked together quite closely. The way that they came up with the design was to have these pieces that went over the bone, and then you could screw through the bone. So it's attached really securely. The reason that 3D printing was designed for making this implant was because it needed to be customised exactly to suit the patient. No human body is the same, so therefore every implant is going to be different. So this is the sternum here. This here is mimicking the rib cage, and these pieces here are what attach onto the ends of the bone. To get to this implant design, Anatomics used the patient's scan data, and that meant that they were able to make an implant design that exactly matched the patient's anatomy. It would be an incredibly complex piece to manufacture traditionally, and in fact, almost impossible. Australia has a really fabulous skills base in biotech and biomedical manufacturing. 3D printing is set to really take advantage of that skills base. Internationally, we're now becoming very well known for our expertise in 3D printing for biomedical applications.
As I mentioned a few times, most of the customers, the companies I work with 3D printing are manufacturers or architects or educators in the engineering space. I don't know very much about medical 3D printing, but I do follow the headlines in that newsletter I get every morning. And this one to me, I would have, if someone had said to me 3D printed sternum prior to my seeing that, I would have thought, yeah, I guess that will happen. But this happened, and it's only going to increase. I think it's Wake Forest that has a program in place currently where they feel 3D printed organs are a matter of when, not if. Again, these are, I don't know much about the medical side of 3D printing, but several times a week I see a headline or an article about it where whether it's prosthetics, whether it's vascular liver tissues, reduce the time and cost of drug testing. 3D printing in the medical world are hand in hand, really pushing the envelope. But when I saw that, I thought that, I didn't realize we were that far along. That was really cool. The next one is super important. This is like incredibly important, right? So I have a 13-year-old son. Last summer he was in a play in Monroe, Hairspray, the musical. And one afternoon an email went out to all the parents saying, would anyone like to volunteer to come over and paint sets tonight? So I was like, yeah, I'll come over and paint sets. So we painted till about 10 o'clock. And as we were wrapping up, I said to the fellow who was the set designer, I said, I work for a 3D printer. You can't have a couple of 3D printers. And he lit up. He thought it was just the coolest thing. And the reason I mentioned it is I knew for certain that there are set designers in the theater world who use 3D printing to print small-scale mock-ups of sets. And you go over with the director, the producer, whoever, and keep changing it. So I said, is there some little thing that I can help out with? I've got the printers. He said, and he was just all excited. And he said, could you print an iron? And yeah, I guess. Why do you need an iron? And so that's a man dread, by the way, in case you haven't guessed. But doing okay? Got it back. There you go. There you go. And he said this ironing board is really rickety, it's the prop they built. He was afraid it wasn't strong enough to take an actual iron. And he said, give me 3D printed iron. I'll mess around with it. So I went into Tinkercad and just started playing around with shapes and trying to make them into something. And I designed an old iron, and they were using the iron, and it worked really great. But the point is, I have no CAD background. I have no background in designing anything. So even I was able to, using basic CAD programs and a 3D printer, I was able to produce this simple little iron in front of play. So from a 3D printed rib cage to a simple iron, it's an incredibly diverse technology. How are we doing, Kaiser? Is this my way of getting the hook, John? My time is up. Is there a timer here? I'll tell you what, I only have a couple more things to show here, but while he's seeing if he can leave the booth, did anyone have any comments or questions up to this point? Any thoughts you want to get?
So when you were talking about the supply chain, and you were talking about how it starts out with crude oil, and they like make the plastic granules for the filament or whatever. Is there any way to like recycle the filament that's being made? And I understand it's like a quality thing with the filament that's being made. So like, just curious, why do like more people are doing that? Right?
Yeah, that is such a great question. So this is called PLA, polylactic acid. The base property in here is cornstarch. Now, the standard industry line, and I don't mean that cynically, is that because it's cornstarch, this is technically biodegradable. Under the right heat and humidity and bacteria conditions, this should start to decompose. On the flip side, I worked with a fellow for a couple of years. He took some 3D printed PLA parts, dropped them in a jar of water, put the lid on, put it in his desk drawer, and every few months he'd pull it out. Those parts were as perfect as when they came off when they came out of the printer. They didn't degrade, they didn't do anything. So on the one hand, yes, these are all recyclable plastics. As far as recycling them and get them to be used again for 3D printing, I don't think anyone's achieved that yet. I don't want to overstate the case here. It would seem to me that's an enormous area of opportunity. I mean, I have failed prints, and what do I do with them? I throw them out, put them in the recycling bin. But if anyone can figure out how to get this back to a pure enough state that it can be 3D printed again, I think there's a tremendous opportunity there. I don't believe anyone's done it yet.
I know the quality that I've seen people with grinders.
Oh yeah.
Also.
Yeah, but you can grind it up. You can grind it up. You can make it into filament again. It's about the quality of the extrusion. When there's a perception among buyers of 3D printers that the reason 3D printing companies are always trying to get you to buy their filament is the perception that they're trying to follow through the Packard model. Get a lot of money for the filament, don't charge a lot for the printer. That's not exactly right. I didn't bring a spool. I should have. It's really important that strand coming out of the spool is consistent for diameter and it's consistent for melting point. So it melts not too much, not too little. So the companies control that very carefully. Yes, you can grind up the print, but are you going to get it back to where it has to be to print well? It's still a developing technology. I have failed prints. Everyone gets failed prints. Any thoughts you want to share? Comments, questions? Yeah.
I've seen people talking a lot now about integrated circuits within 3D prints. How important do you think that's going to be in the next years?
So when you get a chance, look up a company called Voxel 8. They're up in Boston. They are actively pursuing 3D printing circuits, and they've actually created 3D printing circuits. I think they printed the sort of like the body of a drone, which I believe was fairly along in the process of being able to actually work. Their goal, I think their decade-long goal, is to 3D print like an actual communications device, some kind of a phone. I think it'll be huge. It's not going to happen tomorrow or next week, but the big stumbling point today in 3D printing is that we produce parts. We don't produce finished products. And that's something that everyone who's involved in making something is very aware of. You still have to assemble. But give you a silly kind of comparison. So this is a real simple platform jack. This was printed as one part. Okay? If you could 3D print this stapler as one movable object, you've gone from 3D printing parts to 3D printing a finished product. And I do think it'll happen with printed circuits. Voxelate is tackled it head on. I think their goal is by 2025. They feel they're going to 3D print working electronic circuits for like a phone or such device. Anyone else? Yeah.
So I know like when this blows up, there's going to be people making their own products, probably with 3D printers.
Mm-hmm.
And like what I like always wonder was like intellectual property. You know,
Yeah.
you make these products and like it's your own thing, but someone could easily take the file and then print it themselves. So like, what's the process for that?
What's the process? The process is TBD, to be determined. It's a great question, and it's a huge issue. So in that book I mentioned at the beginning, 3D Printing Will Rock the World, he devotes a whole chapter to what is the future of intellectual property. You know, today you create something, you get it patented, it's under your name, somebody wants to use it, they have to pay you for it. But, you know, let's say you made something. We'll keep it simple. Say you made this and it was patentable, and once I print it, even if I'm paying you for the design, nothing stops you from printing 1,000 more, and you may or may not know I did that. There's a big debate about what is the future of proprietary information versus public domain or open source information, and no one has an answer right now. And then you get into all kinds of liability issues. You know, maybe you designed something for a piece of farm equipment, and it has to be printed to really tight specifications because it has to withstand heat and impact and so on. And somebody prints one with a cheaper material. Well, are you liable? He said, I'm not liable. I told people how to do it. Well, how do you know the person's printing is doing it the way it's supposed to be done? There's a huge debate about intellectual property. How do you protect your designs? And is that whole model going to go away? We don't know. It's the right question to ask. And I think my guess is that in the next 10 years, intellectual property attorneys will be kept very, very busy as they try to hammer this out. I'll take it a step further. And this is strictly hypothetical. I haven't actually seen this anywhere. Let's say you had an old John Deere farm tractor. It should work pretty well, but a couple of years worked on it, And a new tractor is somebody $20,000. And you find out that you can get a couple of gears or some little valve cover 3D printed. It might be a few $100s, but it's a lot cheaper than a new tractor, so you get it printed. John Deere could say, hey, that was our part, that was our design. You can't do that. But you're going to say, well, first off, is John Deere going to find out? And secondly, are they really going to take it to court over a few? No, they're not. So this whole area of spare parts, where a manufacturer says, okay, we're moving on to our new products, our new tractors, we no longer make these, and then a few years later, they're no longer making the spare parts for those, but there's still going to be thousands of them out in the market. Someone says, yeah, I can fix your tractor. I'll have those parts 3D printed. There are companies, spare parts of it. That's the most lucrative part of the business. I mean, there's huge intellectual property issues there. And other parts made to safety specifications. All these things need to be answered. Good question.
We're back on.
Oh, hey. Thank you. Would you mind going back a slide? Yeah. Where was I? Was this the guy in drag? Right, the guy in drag. Okay. Thank you. So, go forward. And I mentioned The Economist before, that fellow coming out here with blind. I like to read The Economist a lot. And someone told me when I was in college that I should read it. I would say it's really small print on a sports page. So I certainly was reading it when I was in school. But I read it now all the time. And very recently in January, skip ahead, they did something, I guess, about all of you. They did a special section on what they call millennials, which they called anyone born, I think, between 1990, I think, and like 2010 or whatever. And they said some really good things about you, that you've never had it so good, you are richer, and you will live longer than previous generations. You're very comfortable with technology and your smartphones. People, women or people of different sexual orientations probably have more freedoms today than before. You're also smarter. You're far smarter than I am, and you're smarter than I was when I was in college. You're probably smarter than Professor Reed, but we'll let that slide. And because of better nutrition and so on. But they still call you Generation Uphill, because I guess the job market today has been a little tougher than it's been other years. The cost of education is higher than it's ever been before. And I'm in no way dismissive of graduating with so many thousands, maybe $100,000 in debt. I'm sure that's very, very difficult. I debated quite a bit before putting this in, but I do feel pretty strongly about it. So, okay, you've got some challenges that maybe other generations perhaps didn't, but you are the best educated, most technologically savvy, most tolerant generation in history. And what do I have next year? No, sorry for that. I promise, I'm not getting into any political talk, I absolutely promise. But there are people in the news today very, very loudly saying that, you're screwed. You're the generation where things are, the economy is rigged against you, or this is rigged against you. And I just wanted to leave off on the note that getting back to the changes in material sciences, getting back to the technology now, we have to manipulate those materials into products and designs that we've never had before. I think you've got an incredible opportunity in front of you. There are people 2 and 3 times your age who give up an arm to trade places. And I'm not to get cliched, but I really think in the next 30 to 40 years, you're probably going to be the generation that solves more problems and more humanity than any generation in history. You've got all these tools coming at you right now. It's an incredible time to pull all of these resources together and really tackle problems that we've always known existed, but we couldn't do anything about. So I just wanted to leave it on that note, that I think you've got some incredible stuff in front of you. And I'm a little impatient, I don't mind saying. So now I think we do Q&A. We probably did some already, but did anyone else have any? It doesn't have to be questions, comments, things you've observed, anything else you might want to chime in with.
You see the 3D printed leather?
I've heard about it. I haven't seen it. I've heard about it, 3D printed leather. So at some point we'll probably hear a lot more custom fit. I would think. And then probably locally, you know. Yeah.
Can you go over the need for 3D printers in like your home?
So, when MakerBot was really ramping up, their CEO and founder, Lee Pettis, we talked about 3D printer in every home. Every home will have a 3D printer. And then there were other people in the industry who said that's a bunch of nonsense. Even though the materials are getting more diverse, even though the printers are getting faster, the diversity of materials one printer can print is still pretty narrow. And there's, all kinds of materials in your home. Wood, plastic, formica, rubbers, and wood, it's really diverse. So is a 3D printer going to come along that can do such a diversity of materials and is inexpensive enough that it makes sense to put it in the home? I would say right now that's still a really big question mark. Where, this is my opinion, what I think is more likely is that some people will get it because they like to work with it, hobbyists, whatever. But I think that whole model of local fabrication centers is going to develop more quickly. That's my opinion on it. So I'd say the whole in-the-home thing is still a big we'll see. I'm going to put someone on the spot here. Professor Reep, you're a mechanical engineer, right? Any thoughts or comments you'd rather You have,
When Henry Ford mass-produced cars, all of them were initially black.
that's right.
And you could have any Ford Model T, by the way, which was one of the very few cars you could have, as long as it was black. Once you have the capacity to have more things, then you tend to want them, and you tend to devote your resources to getting them. So this is mostly a comment on the effect on the business model, where you have a bunch of suppliers who may disappear, or their jobs will get smaller because there are a few parts. I have a feeling that there'll be a massive increase in scope. Yes, the scale of any one part or one product will get reduced because of 3D printing, but I think once there are more resources that people could throw at getting a variety of things they want, they will go after that.
Yeah.
And while there will be some change up in the number of jobs and people moving things around, I think you'll end up with about the same amount of people moving stuff around because people will want more stuff.
You'll end up with the same number of people moving stuff around. Right.
They won't necessarily do
they'll
exactly the
be-
same things.
Right, exactly. So
But there'll be a lot of them doing stuff.
today, there are no local digital fabrication centers.
Right.
What if there were 1,000?
Right.
Then all those people working in those centralized environments now go work in localized environments. So I think, yeah, I think we're probably saying something very similar. The jobs will shift, change. We don't know what those jobs will be yet, but it's likely to be something. That's it? All right. Well, I'd like to thank you all very much. I appreciate the opportunity. Thank you to John, thank you to Allison for making this happen. Hope you found it kind of informative. I got some 3D prints here, some Star Wars stuff. Feel free to come up and ask questions. And thank you very much.
Yeah, you're good. I also need to take attendance from everybody before you leave.